Hello, good evening to everyone. I hope my voice is audible. If my voice is audible, then let me know in the comment section. Good evening to everyone. My voice is clear? Audible? Am I audible? Yes or no? So, today we are going to start metrology, right? Today we are going to start metrology, and just a minute, let me set something. Okay. So, I hope am I audible? Everything is clear. So, let's start metrology. Okay. Now, what is the idea behind the metrology? Why we do metrology? Why we study metrology? Why there is a requirement of metrology? My dear student, after manufacturing, it is desired that it is essential to know that whether the part is in the desired dimension or not. If the part is not in the desired shape or dimension, then it is useless for us, right? Then it is useless for us. So, metrology, okay, actually in manufacturing, an exact component, an exact size cannot be obtained in practical process repeatedly. An exact size can't obtain in practice repeatedly. That's why it is therefore logical to consider the variations, okay, variations in the dimension of the part. Suppose that if I am doing machining, it is not possible for me that to produce, okay, that to produce a shaft. Let's say I am doing a machining operation, right? Let's say I am doing what? I am doing a machining operation, my dear. Okay, machining operation. Okay, I am doing a machining operation, and through machining operation I am producing, basically I am doing a turning operation. Let's say I am doing a turning operation, let's say turning operation, and through turning operation I have to produce a shaft. Okay, I have to produce a shaft whose dia is what? Whose dia is 20 centimeter, right? Whose dia is 20 centimeter. And how much unit I have to produce? Let's say I have to produce 100 units or 1000 units. Can tell me, is it possible? Tell me, is it possible that each unit, it is possible practically, is it possible that each unit has a dia of 20 centimeter? Tell me yes or no. Tell me, is it possible that each unit have an exact dia of 20 centimeter? Yes or no? Just give me an answer in yes or no. Okay, just give me an answer yes or no. No, na? No. Got it? No. So, practically or logically, we make some variations. Okay, we decide some limits. Okay, it is not possible that every time I can produce the dia of shaft 20 centimeter. Okay. हट हो गया है क्या? पता नहीं क्या लिख रहे हो, प्रशांत गौर पढ़े. Okay, so practically it is not possible to produce the dia of the shaft every time 20 centimeter. So what we do? We are going to give some variation. I mean a minimum diameter or a maximum diameter. So metrology, here comes a picture. Here metrology comes in a picture, my dear. And in metrology, basically what we do, metrology gives a minimum and maximum variation. Okay, it give a variable or variation. Okay, it give a variation. Let's say metrology, according to metrology, we decide that the maximum diameter, let's say maximum size, okay, size of shaft which is acceptable. okay, let's say, okay, 20.01 centimeter. I mean, according to metrology, we decide that if it is not possible to produce a 20 centimeter dia of shaft, then the maximum size which will be acceptable up to 20.01 means if I make a shaft whose diameter is greater than 20.01 will be what? Will be rejected, my dear student. Will be what? Will be rejected. Okay, will be rejected. Okay, if the dimension is what? Greater than 20.01. Or according to metrology, I will decide a minimum size of the shaft which is acceptable. Minimum size of shaft which will acceptable, and what is that? Let's say 19.98 centimeter. Okay, according to metrology, I have decided that 19.98 centimeter should be the minimum size. If a shaft whose size below than 19.98 centimeter, that will not acceptable according to metrology. Okay, according to metrology. Am I clear? Rejected. Got it. So this is my acceptable zone. In this zone I can accept the product or the shaft. Okay, I can accept the product. So metrology will decide the dimension, the maximum size of the product. The minimum size of the product is not decided by me. It is decided by the condition of metrology. That's why metrology is required. Am I clear? Am I clear? Yes or no? First of all, tell me. Am I clear? Let me know. First of all, let me know. Am I clear to you? Am I clear to you? Yes or no? Are Baba, tell me. Am I clear to you? Why you studying metrology? Is that concept is clear? Why you should study? Why should you study the metrology? Is that concept is clear? So that our wastage is going to be minimized. We have to minimize our wastage, my dear. Now, my dear, I am introducing the basic terminology, which is very, very important. Which is very, very, very important. I am introducing basic terminology which is used in metrology, like basic size, upper deviation, lower deviation, minimum size, maximum size, basics, fundamental deviations. These terminology I am going to discuss, so please pay attention. Okay, please pay attention. These are the very important terminology. Look, I am taking the assembly of what? I am taking an assembly of shaft and hole, right? I am taking a assembly of what? Shaft and hole. Okay, a shaft, I am taking a assembly of shaft and hole, right? Shaft and hole. Now pay attention. Now pay attention. Generally, I will draw a hole. Okay, pay attention, my dear student. Generally, I will draw a hole like in this manner. Okay, I will draw a hole like in this manner. Okay, in the vertical. This is my hole. Okay, this is my hole. Got it? Now, this is what? This is your hole. Or I will make some more modification. Now, let me add one more slide. Now, my dear student, suppose that a assembly is given to you. Assembly is given to you, shaft and hole. Let's say I am talking about first of all hole. I will talk about first of all hole. Okay, I will talk about first of all hole. Let's say in the exam it is given that hole of 20. Okay, now maximum size, there will be a deviation. Now you can see in this example, there is a shaft now. There is a shaft, my dear, there is a shaft. Okay, you have seen in the previous example that it is a maximum size. Then how can you get the maximum size? You get the maximum size. This is the size on which you put 0.01. Okay, this is 19.98. How can you get, tell me, how can you get 19.98? If you are going to minus, if you are going to minus how much? minus 0.02. Am I clear? Am I clear? So, my dear student, this is known as, okay, some basic thing. This is known as basic size. This is known as basic size. Now, what do you mean by basic size? Basic size is a size which is mentioned in drawing. Basic size is a size which is a theoretical size. Let me clear you. Basically, in drawing or in a theoretically, I have written that I need a shaft whose diameter is what? 20 centimeter. But practically it is not possible. Practically the size is going to be vary. So this is a basic size. Basic size is what? Basic size is that size which is mentioned in your drawing or which is theoretical. Am I clear about the basic size? Am I clear about the basic size? Is that basic size is clear? Tell me please, is that basic size is clear or not? Basic size is clear or not? Tell me please, basic size is clear? Now, on the basic size, we apply a deviation. This is a deviation, my dear. This is what? This is a deviation. Now, this deviation is known as upper deviation, right? This is known as what? This is known as upper deviation, right? Which is at the upper side is known as upper deviation. If you apply upper deviation on basic size, then you get the maximum size. Okay. Whenever you apply the upper deviation, it doesn't matter that the upper deviation is positive or negative. It doesn't matter that the upper deviation is positive and negative. Whenever you apply the upper deviation on basic size, you will get the maximum size. You will get a maximum size. Okay, maximum size of the product. And what will be the maximum size of the product? That will be 20.01 centimeter, right? If the dimension is in centimeter. Now, the lower deviation is known as, my dear, the lower deviation is known as, okay, the lower one is known as lower deviation. Okay, lower deviation. Now, whenever you apply lower deviation on basic size, whenever you apply lower deviation on basic size, it doesn't matter that the lower deviation is negative or positive. You will get a minimum size. You will get a minimum size. You will get what? You will get a minimum size. Let's say here the minimum size is what? 19.98. 19.98 centimeter. Am I clear? Am I clear about the basic size, upper deviation, lower deviation, maximum size, minimum size? Are these terminology clear to you? Are these terminologies clear to you? Let me know. Are these terminologies clear to you? Basic size, upper deviation, lower deviation, maximum size, minimum size. Are these terminologies are clear? Now, in between the basic and minimum size, product is acceptable. Okay, acceptable zone, acceptable range or acceptable zone. Beyond the acceptable zone, my dear student, the product is going to be reject. Okay, reject. The product is going to be what? Reject. Okay, reject. The product is going to be reject. Am I clear? Now, suppose that I am discussing about these basic terminology for whole. Let's say I am going to discuss basic terminology for a whole. Let's say, okay, I want to discuss about whole, right? I want to discuss about whole. Now, for a whole, let's say I will write. Let's say I will write 20, right? 20 plus. Okay. Now, see, 20 plus 0.4, okay, 20 plus 0.2. Now, see, both the deviations are positive. Both the deviations are positive. So, it doesn't matter. Deviation can be positive or negative. It doesn't matter. The only thing is that whenever you apply the upper deviation, you will always get the maximum size. whenever you apply the lower deviation, you always get the minimum size. Am I clear? I am talking about the whole. So, this is the upper deviation, my dear. So, what will be the maximum size? When you apply the upper deviation on basic size, you will get the whole of maximum size, that is 20.4. Okay. When you apply the lower deviation on basic size, then you get the minimum size of the whole, let's say 20.2. It is what? It is a minimum size and it is a maximum size, or you can say it is a upper limit. Sometime we called in short upper limit, sometime in short we called lower limit. Maximum size is also known as upper limit. Maximum size is also known as upper limit. Minimum size is also known as lower limit. Now, how can I represent on a diagram? Okay, let me draw a diagram. My dear, let's say there is what? I am drawing a hole here. Okay, I am drawing a hole here. Okay, right? I am drawing a hole here. So, pay attention. Now pay attention, please. Look. This is the hole. Actually, the line represent the hole. Now, one of them line is what? One of them line is a zero line. This red line is known as, my dear, zero line. Okay, listen me carefully. The red line is known as zero line. Am I clear? This red line is known as zero line. Okay, this is what, my dear, zero line. Now, why I called a zero line? Because with respect to zero line, I will find out whether the deviation in positive side or negative side. Right? Now, I am going to fix one line. Now, I am talking about the whole. My dear, I am talking about the whole. Okay, so for whole, you see the basic size is what? This is what? This is the basic size. For whole, this is what? This is the basic size. So, mention the whole. It is, my dear, it is a basic size. Okay, it is what? It is the basic size, right? Of 20 centimeter is the basic size. I am representing the diagram. How can you draw in a metrology? Right. Now, according to that, your maximum size is 20.4. Now, you have to draw the maximum size, okay, in a diagram. Look, please see carefully. Please see carefully. Right? Please see carefully. This is my hole. This is my hole. Okay. To make the hole proper, you either shade it, represent that it is a hole. It is a one side surface of the hole. Now, the other side, I am drawing the maximum size, my dear. I am drawing the maximum size. For my reference, I am drawing this line. For my reference, I am drawing this line, so that the diagram should be, diagram should be proper. Now, the maximum size of hole, see the maximum size of hole. See the maximum size of hole. Right. Now, my dear, this is what, okay, please try to understand. This is what here, this is basically the maximum size of the hole. Am I clear? This is what? This is the maximum size. See, this is a maximum size. Now, I am going to shade. So, this is a hole. Am I clear? Am I clear? My dear, this is maximum size, or you can say upper limit, means 20.4. 20.4. Is that clear? Is that clear? Is that clear? Yes or no? 20.4. Now, the next size is minimum size, means lower limit. How can you draw? It is 20.4. Before that, try to understand, my dear student, please see this fiber. Actually, this fiber is away from zero line. How much? away from zero line, see, away from zero line. Please see, I am drawing again for you people only. Okay, see please, see properly, see the fiber of the maximum size of the hole which is away from the zero line, right? This is what? This is upper deviation, and you know upper deviation is what? Upper deviation is 0.4. Am I clear? Am I clear? Is that point is clear? Now draw the minimum size. You know the minimum size is 20.2. Now draw here the minimum size of the hole. I am drawing the minimum size of the hole with a different color so that you can understood. Now this is the minimum size hole. Now this is a minimum size hole, my dear, right? This is a minimum size hole. If I will represent, so see, this is the minimum size hole, means it is a lower limit. Lower limit is what? 20.2. It is a minimum size. Am I clear? Now see the fiber of the minimum size of the hole. Now see the fiber of the minimum size of the hole is away from the zero line by that much distance. Is away from the zero line by that much distance. So this is known as what? Lower deviation. And lower deviation is what? 0.2, yes or no? 0.2, yes or no? Tell me, are you getting my point? Tell me, are you getting my point? Yes or no? First of all, tell me, are you getting my point? Yes or no? So this is my okay, this is my minimum size. Now the acceptable zone, my dear, the acceptable zone is what? This is the acceptable zone now, where the product is going to be accept. The product is going to be accept between 20.4 to 20.2. So the zone is what? 20.4 minus 20.2. It is plus 0.2. It is plus 0.2. Basically, it is known as tolerance. Tolerance means how much you are tolerating, how much I am accepting. How much I am accepting. So this much type of product I am accepting, this much type of dimension I am tolerating. So this is known as my tolerance zone, or you can say acceptable zone. So how can you mention that thing? You get this tolerance zone, you get that tolerance, okay, you get that tolerance. How can you get that tolerance? You get that tolerance, that is maximum size 20.4 minus what? 20.2 minimum size, it is 0.2. So see here, please, in the diagram, maximum size minus minimum size. This is what, my dear? This is what, my dear? This is the tolerance. I am drawing it with a different color. This is the tolerance, my dear. This is what? This is a tolerance zone. This is what? This is a tolerance zone. This is what? This is a tolerance zone. Am I clear? Am I clear? Am I clear? So this is a tolerance. This is all about the hole. Now, am I clear? Yes or no? Tell me, please. Yes or no? We talked about the hole. This is a way to represent the hole. Okay, this is a way you can represent the hole. This is a way you can represent the hole. Am I clear to you? Tell me. Am I clear to you? Yes or no? Tell me, am I clear to you? This is the minimum size, as you can say. Okay. So now we try to understand how to okay, draw a shaft in the metrology. Okay, in a shaft in a metrology. Let's say there is a mention that a shaft is there. Right? A shaft is there. And let's say the dimension, let's say her shaft is what? 20 minus 0.1, okay, and minus 0.3. Again, here the deviations are both negative. It doesn't matter, my dear. This is the upper deviation. By applying the upper deviation, you always get the maximum size. This is a lower deviation. You always get the minimum size when you apply the lower deviation on basic size. Okay, when you apply the on the basic size. So what is the upper limit, my dear? What is the upper limit? Please see. Upper limit. Okay, upper limit means what? Maximum size. What will be the lower limit? What will be the lower limit? Lower limit what? Minimum size. So upper limit is 20 minus 0.1. It means 19.99 is the minimum size of the shaft. If you're taking the dimension in centimeter, then you take it in centimeter. This is a lower deviation. If you apply on the basic size, then you will get the minimum size, that is 19.97 centimeter. Am I clear? Am I clear? So it is the acceptable zone where you can accept the product. So what is the range of this zone? This is known as what? Tolerance. As you know, tolerance, the range of the shaft is tolerance. And how can you get? Upper limit minus lower limit, right? Upper limit minus lower limit. So 19.9 minus 1, it comes again 0.2 plus 0.2. Am I clear? Am I clear? Beta, what does it mean? My dear, what is it? What does it mean? It mean? Here see, the tolerance comes in positive. Here see, please. Here please see, the value of the tolerance comes is what? 0.2 plus 0.2. Positive. Sorry. Oh, yes. It's a 19.9. So, okay, what I will do, okay. It's a 19.9, right? And it is 19.7. Clear? 19.7. Yes. So, here upper limit minus lower limit comes what? Tolerance. My dear, whether the upper deviation or lower deviation negative, whether the upper deviation or lower deviation positive, it doesn't matter. It means here tolerance always comes positive. See, tolerance comes positive. Whether the deviation are positive, whether the deviations are negative, it doesn't matter. We understood one thing, that tolerance always comes positive. Am I clear or not? Tell me, am I clear or not? Tolerance always comes positive. Am I clear? Is that point is clear? Now, how can you represent this thing on a diagram? In the same diagram, how can I represent? Okay, I am representing the same thing. Okay, here. Suppose that, okay, let me draw here. Let me draw here the same thing. This is the zero line, this is the basic, this is the line. Now, tolerance always should be not always should be 0.02, it is always should be positive. Chaman Khan, it is always positive. 0.2 comes by coincident. Suppose that here, if I take what, let's say, instead of 0.3, if I take what? Instead of 0.3, minus 0.3, if I take, let's say, minus 0.4. Okay, then here, minus 0.4 means 19.6 is a minimum size. Then what is the tolerance here? Again it is positive, but it is what? 0.3. Yes or no? Am I clear? Tolerance always positive. Right. Now, let's draw on the diagram. How can you draw a shaft here? How can you draw a shaft here? Let's draw a shaft. Now, try to understand. Okay, try to understand. Now, I am drawing the maximum size of the shaft, my dear student. I am drawing a maximum size of the shaft. So, this is the maximum size of the shaft. Right, this is a maximum size of the shaft which I have drawn. So, I am representing that it is the maximum size, means it is what? Basically, it is the upper limit. It is what? Upper limit of the shaft. Right, upper limit of the shaft. What is the size? The size is 19.9 centimeter. Okay, it is a zero line, means what? It is a zero line, my dear. Please try to understand. It is a zero line. Okay, it is a zero line. It means what? the fiber of this shaft is away from zero line. How much? Negative 0.1. Okay, so it is in the negative direction. It is in the positive direction, right? From this side of the zero line, the things is positive. From this side of the zero line, the things is what? Negative. Am I right? Am I right? So write down here. So it is what? Basically it is what? It is the upper deviation. My dear, it is what? It is upper deviation. This is what? This is upper deviation. And upper deviation, you know, it is minus 0.1. Am I clear to everyone? Am I clear to everyone? Now, I am drawing the minimum size of the shaft with a different color. Let's say this is my minimum size of the shaft. Okay, let's say this is my minimum size of the shaft. Okay, this is my minimum size of the shaft. Okay, this is my minimum size. This is my minimum size of the shaft. Now, here see here, this is the minimum size, means what? Lower limit, my dear. And what is the lower limit? 19.4, right? 19.4, right? 19.6. 19.6. Am I clear? Am I clear? Am I clear? Beta, how can you represent the tolerance here? Tolerance always be what? Upper limit minus lower limit always gives you what? Always gives you tolerance. This is what, my dear? This is what? This is the tolerance. See, this is the tolerance. This is the tolerance. This is the tolerance. This is the tolerance. Tolerance. Am I clear? Tolerance. Now, you have to represent the lower deviation also, na? So this is, my dear, please see the lower deviation also, right? Or lower deviation also. Now see, the lower limit of the shaft is away from the zero line by that much distance, so you will represent lower deviation. Now is that clear? Now you understood how to represent shaft and hole in a diagram? Are you getting the thing? Are you getting the thing? Yes or no? Tell me. Are you getting the thing? Yes or no? Are you understand? Do you understand what is the maximum size? I mean, what is the upper limit? Okay. Do you understand what is the upper limit? What is the lower limit? Okay. Do you understand what is the lower deviation, upper deviation? Do you understand about the tolerance? Do you understand tolerance always be positive? Do you understand this thing? Do you understand this thing? Please remember. Please remember, it's a very important thing. Now, I am introducing one more concept. Which is known as fundamental deviation. Okay, I am introducing one more. Just a minute. I have an important call. Just a minute. Give me a second, please. Give me a second. Yes. Fundamental deviation. One more concept is remaining, that is fundamental deviation. Okay, what is fundamental deviation? Fundamental deviation. What is fundamental deviation? What is fundamental deviation? What is fundamental deviation? What is fundamental deviation? What do you mean by fundamental deviation? Now, do you know about the fundamental deviation? Basically, this is a deviation, either the upper or the lower deviation, which is nearest one to the zero line for either a hole and shaft. Look, what is fundamental deviation? In my simple terminology, if you want to understand, then listen to me. Otherwise, it's your wish. If you want to read the book definition, it's your wish. What is fundamental deviation? You have to select the product. I am talking about the fundamental deviation for what? Hole. I am talking about the fundamental deviation of what? Hole. Now, how can you decide the fundamental deviation? My dear, you have to select the nearest distance. You have to select that hole. My dear, you have to select, suppose you are finding fundamental deviation for hole. Suppose you are finding fundamental deviation for hole. You have to select that hole which is nearer to zero line. Now tell me, which hole is nearer to zero line? Which hole is nearer to zero line? You have to select that hole which is nearer to zero line. Now tell me, which hole is nearer to zero line? Yes, please tell me. You have to select that hole which is nearer to zero line. Then I will tell you about the fundamental deviation of the hole. Now tell me, which hole is nearer to zero line? Is that the maximum size or is that the minimum size? Is that the upper limit of the hole or lower limit of the hole? Which hole is nearer to the zero line? Yes, very good, Akash, very good. Lower limit of the hole means that fiber. Okay, so that fiber is nearer. That fiber is what? That fiber is nearer to the hole. Now see the distance. See the distance from the zero line. See the distance from the zero line, my dear. See the distance from the zero line. My dear, see the distance. Okay, see the distance. Actually, the distance is equal to what? It is a lower deviation. The distance is equal to what? It is a lower deviation. So here, the fundamental deviation is what? Fundamental deviation for hole is equal to lower deviation. Fundamental deviation here, fundamental deviation of hole here in this case equal to lower deviation. Am I clear? So whenever you have to see the fundamental deviation, then you have to see the nearest one to the zero line. Okay, nearest one to the zero line. I will write the definition if you want. You have to see nearest, okay, nearest one to the zero line. Okay, which fiber of the product is nearer to the zero line, that become the fundamental deviation. Am I clear to you? Now I will find out the fundamental deviation for shaft. Now tell me, what is the fundamental deviation for shaft? Now tell me, what is the fundamental deviation for shaft? Now tell me, what is the fundamental deviation for shaft? Tell me, Baba, what is the fundamental deviation for shaft? Tell me, what is the fundamental deviation for shaft? The fundamental deviation for shaft is what? You have to see which fiber? You have to see a fiber which is nearest to the zero line. So upper limit shaft, here you can see the upper limit shaft is nearer to the zero line. So here the fundamental deviation become equal to what? Upper deviation. The fundamental deviation equal to what? Upper deviation. Am I clear? Am I clear? Crystal clear? The point is crystal clear. Now are you getting the meaning of all the terminology? Now are you understand the all terminology? Are you able to understand now all the terminology? Yes or no? Tell me please. Tell me yes or no. Now is that clear now? Now let's move. Let's move. Okay. I will mention something also. This is what basically, this is a tolerance. Okay. This is what? This is a tolerance. Okay. This is tolerance. 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 Right. This is what? This is tolerance. Tolerance. Right. This is what? This is the tolerance. So let's move. Now I have discussed all the basic terminology. Now I am going to move in the next slide so that we can move further. Okay, we can move further. Now the tolerance. I am going to revise some concept about the tolerance. You have seen what is tolerance, my dear? One thing you know, tolerance is what? Tolerance is always upper limit minus difference of upper limit and lower limit, right? Okay, tolerance is a maximum permissible variation. Tolerance is maximum permissible zone where the product is acceptable, right? Here the tolerance is uni or bilateral. Maybe you can't understand this point, so I am making a question mark here. I will clear just after this slide. What is the meaning of unilateral and bilateral, right? Now you have know that tolerance is always positive. So these are the questions which comes in your theoretical exam. Okay, fact about the tolerance. These are the fact about the tolerance that you should know. there is a chance that a theoretical question will becomes in your any exam, maybe a GATE or any other exams, right? Now let's move and try to understand what do you mean by unilateral and bilateral system. My dear, uni or bilateral system. So to explain this uni and bilateral system, I have to take what? I have to take some example. Then after you will understand. Okay, I will take an example. Let's say unilateral limits, right? I will explain about the unilateral limit. Got it? Let's say I will take an example of shaft, because as you have seen, to draw a shaft easy, to draw a shaft easier than the hole. That's why I always take example of shaft, right? Let's say I'm taking a shaft, I'm drawing a shaft, okay, I'm drawing a shaft, I'm taking a shaft, okay, I'm taking a shaft, okay, unilateral na, okay, then 25, let's say plus 0.4 and plus 0.1. My dear, it is a unilateral system. My dear, it is a unilateral system. Why? Look, first of all, draw it. Draw and understand the thing. Very simple. Draw and understand the thing. Very simple. Draw the basic size. This is what? This is a basic size now. Draw the basic size. This is a basic size. Right? This is a basic size. Now, here, the maximum size of the shaft is what? 20.4. This is what, my dear? This is the basic size. Right? This is what? This is the basic size, that is 25. This is a basic size. Right? Now, maximum size is 25.4. Look, maximum size is what? 25.4. So, I am drawing it with a different color. This is a maximum size. Okay. This is a maximum size of the shaft. Now, see here. This is a maximum size of the shaft. Clear? 20.4. 25.4, right? Or you can say upper limit. Now, minimum size, draw the minimum size. Now, this is the minimum size of the shaft. Okay, this is the minimum size of the shaft. This is, and it is the lower limit. Now, my dear student, draw the limits here. Draw the limits here, right? Draw the limits. This limit, okay, draw the limits here. Okay, draw the limits here. Okay, draw the limits. Now, see here. See here. See here. My dear, all the deviation, I mean upper deviation, this is what? This is what? Upper deviation. And let me make the zero line first. This is a zero line. This is what? Zero line. Right? This is zero line. Now, all the deviation, that is your upper deviation and your lower deviation, they lie on a same side of a zero line. They lie on a same side of a zero line. That's why this system is what? That's why the limits are what? Unilateral limit. Am I clear? Am I clear? And here the tolerance will lie on a same side. Okay, on a one side of the zero line. That's why the tolerance is also called as what? This is the tolerance, my dear. This is the tolerance. This tolerance is unilateral tolerance. Am I clear or not? Am I clear or not? Tell me yes or no. Tell me yes or no. Is that clear or not? Okay. So, whenever the deviations lie on a same side, then that limits are known as what? Unilateral limit. Sir, zero line will not that be below LL? Hai? But zero line is a reference line, na? Zero line is a reference line. On this side of zero line, I will take the positive. Below the zero line, I always take negative. Oh, sorry. You are right. You are right. Ha. You are right, my dear. I am really sorry. Yes. Actually, in my back of the mind, other example was there. You are right. Let me draw again. This is a zero line. Okay. Yes, this is a zero. Look. Now, this is a basic size. Simple. Let me draw again. This is a basic size. Okay. This is a basic size of, 25. This is a basic size of 25. You are right. This is a basic size of, because back of my mind, different example was running. That's why I have drawn. Now 25. Previous example was running in my in back of my mind. That's why I have written. Yeah, 25. Got it. So here, let's say the maximum size is 25.4 now. The maximum size is 25.4. Okay, this is the maximum size of the shaft. This is the maximum size of the shaft. Okay, this is the maximum size of the shaft. Look, this is the upper, this is what? Upper limit. And this is what, my dear? This is, you can say, upper deviation. Right? This is what? Upper deviation. Upper deviation. Upper deviation. Right? Upper deviation. Now, the minimum size is what? 25 point and upper deviation is what? 0.4. Now, minimum size is 25.1. Now, let me draw the 25.1. So here, this is the next size. Okay, this is the next size. Now, see, this is what? This is the lower. This is the lower limit. This is the lower limit. This is what? Lower limit. Right. Now, see. Now, see here, my dear. See here, my dear. Here, this is what? This is a lower deviation. Now, see, both the deviation are lie on the same side. Both the deviation are lie on the same side. Okay, on on the same side. This is what? This is a zero line. Na? This is a zero line. Right? This is a zero line. So that system is known as what? Unilateral limits or unilateral system. Now, what is the tolerance? This is a tolerance. So tolerance here lie on one side of the zero line. So that's why the tolerance is what? Unilateral tolerance. Now am I clear? Now am I clear? Okay. Now am I clear? Now I will take a special case. Okay. I will take a special case of a unilateral limit. Let's why I will again take a shaft. I will again take a shaft and I will write 25 plus 0.0, okay, minus 0.2. Now, is that a unilateral or bilateral? Tell me, is that the unilateral or bilateral? If you are facing any confusion, draw. If you are facing any confusion, then the solution is draw. Simple. Okay. Suppose that this is, my dear, this is the basic size. This is what? Basic size, that is 25. Now, maximum size is 25 point what? Maximum size is 25.25. Okay, the maximum size is 25. See, this is my maximum size, means this is what? This is the upper. This is what? This is the upper limit. Right. Now, the minimum size is 24.8. Okay, because minus 0.2 na, 24.8. So let me draw the minimum size here. Let me draw the minimum size here. This is a minimum size, my dear. This is a minimum size. See here, see. This is what? This is the minimum size. Now, this is the lower limit, right? 24.8. 24.8. No bilateral. It is not a bilateral. Again, it is a unilateral system, right? Now, see here also. See here also, my dear. See here, please. Here, this fiber. Here, this fiber will lie here. This fiber, okay, this fiber is what? Your lower deviation. Here, upper deviation is what, my dear? 0. This is a special case. If any one of the deviation, if any one of the deviation lie on a 0 line and other will lie in the negative or 0 side, sorry, other deviation will lie in negative side or positive side, that system is also take as a unilateral system. So it is also a unilateral system, because after all it is, okay, if it is a special case, if one deviation will lie on a 0 line and other will lie below the negative or above the positive, okay, above the 0 line, then that deviation is known as what? That deviation is known as what? Unilateral system. Am I clear? Am I clear? For a positive, suppose that if you take let's say 25, suppose that if you take 25.0 and minus 0.0, then it is also a unilateral system. It is also a unilateral system, my dear. Okay, it is also a unilateral system. If you can't believe, then draw and decide. Simple. It is also a unilateral system. Am I clear or not? It is also a unilateral system. What is the maximum size? 25.02. Right. What is the maximum size? 25.02. Now see, this is the maximum size, 25.02. 25.02, right? It is also a unilateral system. Okay, upper limit is what? 25.2. Okay, 25.2. Now, one of them deviation is what? 0. So this is what basically, this is the shaft. This is the shaft, my dear. This is the shaft. Okay, this is what? This is a lower limit, that is 25. Okay, here one of the deviation will lie in a positive side. Here one of the deviation will lie in a positive side. See here, this is what? This is the upper deviation, and here the lower deviation is what? 0. Again, it is a unilateral system. Am I clear to all? Pintu, Pintu, am I clear? Am I clear? It is what? It is again a unilateral system. Is it clear? Are you understand what is the difference between, are you understand the unilateral system? Now are you understand the unilateral system? Now, it's time to discuss about the bilateral system. It's time to discuss about the bilateral system. Let's say, if one of the limit, let's say 25 plus 0.2 minus 0.1, it is what? It is what? Bilateral system. Why? Because one deviation will lie above the 0 line and one deviation is lie below the 0 line. So that system is known as what? Bilateral system, right? That system is known as what? Bilateral system. If you are not getting the things, then draw and try to understand. Okay, and draw and try to understand. This is again, I am drawing a shaft. This is my shaft basically. I am drawing a shaft, 25.01. Okay, 25.01. So draw and try to understand. This is what? This is a shaft of the bigger size, that is 25. Okay, this is the upper limit. Okay, 25.2. Now 25 minus, so this is what? This comes out 25, this comes out this. Okay, this is a thing. Now see, one of the deviation lie in positive side and one will lie in a negative side. This is the upper deviation and this is the lower deviation. So this system is known as bilateral, right? And the tolerance is also known as, the tolerance is what? Bilateral tolerance. Am I clear? The tolerance is what? Bilateral tolerance. Am I clear? Yes or no? Let me know. Is the concept is clear? Is the concept is clear? Tell me, Baba, is the concept is clear? Yes or no? Simple. Is the concept is clear? Unilateral, bilateral systems are clear? Yes or no? Unilateral and bilateral systems are clear. Huh? These are the basics today we are discussing. Today we are only discussing basics. Tomorrow onward I will discuss the type of fit. Then after I will discuss the gauge design. Then I will discuss some basic, some type of metrological instrument. Then your metrology is finished. Okay. Then after your metrology is what? Finished. So these are what? Unilateral, bilateral. So here, this is the meaning. In tolerance, there is a point. The tolerance may be uni or bi. Now you understood. Now you understood what is the meaning. The tolerance may be uni or bilateral. Okay. Now you understood. It depends on the system. Unilateral limits or bilateral limits. Tolerance will depend on the unilateral limits or bilateral limits. Now this point is over. Now let me discuss one more point. Oh, there is a question. Let's try to answer this question. Let's try to answer this question, my dear. Please give the answer. What is the answer? Yes, B, bilateral. 25, actually if it is not visible, plus minus 0.05. This is the data. So it is what? It is a bilateral. Now one more question. Now tell me the answer. One more question. Now tell me the answer. Tomorrow we will discuss types of fit. Okay. Tomorrow we will discuss types of fit. Tomorrow is also very important class. And day after tomorrow I will discuss gauge design. Look, I am drawing a diagram. I believe in metrology, if you are able to draw the diagram na, then you will never do any mistake. This is a zero line, sorry, and this is a zero size, right? A shaft has a dimension, okay. This is a basic size, right? This is a basic size, that is 35. Now, here the size is 35 point. As you know, it is clearly visible that this is what? This is a zero line, my dear. This is zero line, right? So, this is a shaft of upper limit, and this is a deviation. That deviation is known as what? Upper deviation, and it is what? Minus 0.009, minus 0.009. Now the lower deviation or lower limit, here the lower limit of the shaft is, this is the lower limit of the shaft, okay, this is what? This is a lower limit, lower limit. If you see the fiber of that shaft, it is below from the zero line, okay, this is what? Lower deviation, simple. And this is what? This is tolerance, this is tolerance, right? This is tolerance. Yes, everybody is right, option D is the answer. So, what he is asking? Fundamental deviation. My dear, it is simple na, it is what? It is a fundamental deviation, yes or no? Simple. From the figure it is simple, it is a fundamental deviation, because fundamental deviation is the nearest one from the zero line, so it is the nearest one. And what is tolerance? Tolerance is what? Tolerance either the maximum size minus minimum size, or either the upper deviation minus lower deviation. So, upper deviation minus lower deviation comes what? This zone will becomes what? 0.0016, so option D. Am I clear? Am I clear? Understood? Today you understood the concept. So tomorrow I will start the types of fit, right? Tomorrow I will start types of fit, like your clearance fit, transition fit, interference fit, very important, okay, very important. And day after that I will start what? I will start the gauge design, this is also very important. So consequently, I mean in the series, okay, the first 3 days for the metrology are very important. The first 3 days of the metrology are very important, because today you have understood the basics, tomorrow you will understand the type of fit, day after tomorrow you will understand the gauge design, right? So 3 days for the metrology are very important. The 4th day, that is the metrology instrument, and you know you have to just learn the formula. सर जी शेपर में डबल स्ट्रोक का क्या मीनिंग है? बेटा कल बताया तो था ध्रुव, डबल का मतलब क्या? कटिंग और फिर रिटर्न, यही तो डबल हो गया. ये पूरा स्ट्रोक है, लिखा तो था कल ध्रुव सिंह, कटिंग एंड रिटर्न, दिस इज अ डबल स्ट्रोक, राइट? दैट इज अ थिंग. डोंट कंफ्यूज. डबल मीन्स व्हाट? दिस स्ट्रोक and this stroke. How many stroke? How many strokes? Double stroke in a one single stroke. For complete one stroke there will be a double stroke. For complete one stroke there will be a double stroke, like cutting stroke and return stroke. This is the meaning of the double stroke, right? Am I clear, Dhruv Singh? Am I clear? Yes or no? Actually double stroke means a single stroke. In single stroke there will be a cutting and there will be a return. That is the meaning of double stroke. So I hope you understand the things. So tomorrow we are going to meet, okay, at the same time, at the same channel, with a new topic of metrology, that is your types of fit. Okay, thank you very much.